as is multivariable or machine learning types of algorithms. So I'm going to show you pretty much the same thing, but with a different view. Instead of a control chart of one parameter called the univariate control chart, I'm going to show you an example of a machine learning visualization for basically the same issue. And so this basically is a three-dimensional portrayal of all those 40 batches. And the control is an ellipse, and it's an ellipsoid, is actually the equivalent of the 2 sigma line. It's a 95% confidence limit. And if I showed you a 3, it would enclose all of the data sets, all the data points. All these are the individual points, the orders that we talked about beforehand. And so if I zoom out, I can show you the faults that, there's 6 faults that Professor Ricker had put up there, and there's actually 15, but I didn't want to clear this up too much. This is the one associated with the A feed, which I've told you before. These 2 are associated with the condenser system problems, and the 3 of these are associated with the reactor. So what we found, and it's described in the patent, is symptoms across many different variables that go to a common root cause all appear, if you will, in the same kind of quadrant of this new space that's part of what we call a principal component analysis, which is reduce the dimensions of that 49 parameters down to, in this case, 3 parameters. And so we can then visualize, again, here is the control. All the batches that are kind of within that control. You can zoom in and you can get yourself dizzy by looking around and zooming in, zooming out. But these are the faults, if you will, associated with the other batches. And so what I'll do is go into one of those and follow the particular large bars, if you will. We found operators find this very intuitive. And then I can get down to the univariate chart, in this case, the condenser. And I've got the same kind of a presentation where I have an indication of something wrong, and I can click on what I think is the norm. And you can see, again, there's a disturbance, a difference in the time domain. And all I've done in this is taken a couple of simple statistics, used an automatic program to generate that on a lot of data, and immediately I can pick up the faults that the professor had documented, if you will, on that website. So I know my time is out, and so I just wanted to thank you for the opportunity to show you this, and I'll turn it back to Dan for any questions you might have.